Hi guys, in this video we're going to be talking about the quadratic formula and the discriminant. And so both of these should not be new to you. So let me just kind of throw some things on here. Okay, so when you have a quadratic function or quadratic equation in standard form, the coefficient of the x squared, that's your a, and then this is your b, and then your constant is c. And so those are the a, b's, and c's that show up in here. So when you are doing this, you need to make sure, this is kind of a big deal, that you set it equal to 0. So what you're basically finding are, like if you want to think of it from a graphing perspective, it's the x-intercepts, but from an algebraic expression or perspective, it's the values for x when y is equal to 0. So that's what's going on there. So we have, let's go ahead and talk about the discriminant. So I want to point out this piece right there. That is going to be the discriminant. And so that's going to tell us a few things. So let's think about, like, if we, think about this from underneath the square root. So if it's positive, if this is just a positive number in here, and I take the square root, then we have two solutions, because we're going to have negative b plus blah, blah, blah divided by 2a, and negative b minus blah, blah, blah divided by 2a. So that's going to be two real solutions for our answer. So what the discriminant does is it kind of tells us what our answers are going to look like. So if a lot of times we can just do this part in our head, square whatever this is, and subtract 4ac. So it'll kind of give us an idea of where we're going with the problem. Okay, so let's talk about what would happen if this were a negative number. So if I'm taking a square root of a negative number, then an I would come out of that. And so that's where we would have, we'd still have the plus or minus, but we'd have two complex answers. So remember, we're not talking about complex answers. I'm talking about the a plus bi. Okay, and then the last thing is, what if this b squared minus 4ac is a 0? So what if this whole thing was a 0? Well, that plus or minus kind of falls out of place, and we would just have negative b over 2a. So if this is a 0, we would have one real solution, or one real answer. We're going to start off just by finding the discriminant. And it says state the amount and types of solutions. So what it's talking about is this, like two real, two complex, one real. So that's what it's asking. And then it says, then solve using the quadratic formula. Okay, so the discriminant is negative. So let's go ahead and start with a, b, and c. So a is 3, b is negative 5, and c is 4. So b squared 25 minus 4ac, 4. Okay, so I'm going to end up with two complex answers. So I know that when I do the quadratic formula, I'm going to come up with some yucky answers that have some i's in it. So let's see. X equals negative b plus or minus b squared minus 4ac. So I've already found that. So I'm just going to go ahead, and put negative 23 in here. And then all over 2 times 3. So I have 5 plus or minus I square root of 23 over 6. Now, when we have, it needs to be in the a plus bi form. So I'm going to have to separate this. So 5/6 plus or minus, and then I'm going to separate this as bi. So like square root of 23 over 6i, and pull that I out. So that's my first problem. Let's go ahead and do these next 3. See if you can do them on your own. So for this one, I found my discriminant as 20. So I'm going to say negative b plus or minus square root b squared minus 4ac, I already found that, all over 2a. So I can simplify that. A 4 is going to come out, and so the square root of 4 is 2, so it's going to be 2 square root of 5 over 2. And then I'm just going to simplify this again, because -4 divided by 2, that is -2. And then I have a 2/2, which is 1. So my final answer is going to be -2 plus or minus square root of 5. Okay, keep going. Okay, a couple things I want to say about this problem. First of all, this problem and this problem wasn't set equal to 0, so I went ahead and moved those over. So hopefully you figured that out. But the second thing is that I could go through and divide everything by 4 to make the number smaller. You're totally able to do that. So I didn't, because I didn't know how many of you guys would think about that, but I just wanted to point that out. Sometimes it's really nice to make those numbers a little smaller. So I ended up with my discriminant as 0. So here, I didn't even go back. So let's go back to this one here. So we had 2 complex answers. This one, we're going to have 2 real answers because it was a positive 20. And this one, because it's 0, I have 1 real answer. So I'm going to show you why that is. So so let's do the quadratic formula. So -b, so 8 plus or minus square root, and that's 0 underneath the square root, over 2 times -4. So if you'll notice, that just cancels out, because plus square root of 0 is 0, minus square root of 0 is 0. So basically, I just have 8 over -8, which is -1. So that is my only real solution there. Okay, so go ahead and try this one. Okay, so this is a positive number, just like this was. So I'm going to have 2 real answers again. And let's go ahead and apply the quadratic formula. So -b, so opposite of b, plus or minus square root of 361 over 2a. So there's really nothing I can do with square root of 61 or 361. So I am just going to keep it like this and call it good. Okay, so this one, think back to like a couple chapters ago where I want to get rid of these. So I'm going to multiply everything through by the LCM. So our LCM in this case is going to be x squared. So I'm going to multiply each thing by x squared. So I have, so I have -1. And then notice that this, because these cancel out. Okay, and then this cancels out just one of those x's. So I have plus 4x, and then I have nothing to cancel out down here. So I have plus x squared equals, and again, but that's 0. So I'm just going to clean this up a little bit. And so let's go ahead and find the discriminant and see what happens. So I have 16 minus 4ac. So I have 20 again, so I'm going to have 2 real answers. So let's go ahead and -b plus or minus square root of 20 all over 2a, like that. And again, I can simplify the square root of 20 as 2 square root of 5. And then simplify this. I feel like this was the same answer as before. So my final answer is 2 plus or minus the square root of 5. Okay, now let's do a word problem, and this will be our last one. So the difference, so subtraction, of 2 positive numbers is 1, and the product is 16. Okay, so I'm subtracting 2 numbers to get 1, and I'm multiplying 2 numbers to get 16. So let's call the 2 numbers x and y. So x minus 1 is 1, and x times y is 16. So I think I want to use substitution. So I'll say x is 1 minus y and plug that in for x down here. So and just distribute this y. So I have y squared minus y, and I'm just going to say minus 16 equals 0. And then I'm going to use the quadratic formula. So go ahead and do that and see what you get. Okay, so these are actually the two numbers that are added and multiplied together. I'm sorry, subtracted and multiplied together to get our different numbers. So I have 1 plus square root of 65 over 2 and 1 minus square root of 65 over 2. Those would be super yucky to add or multiply together. But that's it, guys. We are done with this lesson.